So here we're going to talk about fishnet and crosshatched fishnet rendering, what we mean by that. We're going to apply it to this whole brain MRI scan here. So this scan is a 0.7 millimeter, 7 Tesla MRI scan of the whole brain that was skull stripped. And this is how clinicians usually look at a brain like this. They will just scroll through the slices. Okay. And there's the ventricles, and you can see subcortical structures as well. Okay, and so when you have mixed reality, how do you bring a 3D volume like this into the 3D space so that you can not only see the slices but get a sense for the spatial three-dimensional volumetric manifestation of this brain? Okay, so one way to do it is to model just the surfaces, and that's commonly done. And so you can create sort of like a balloon, if you can imagine that, just all around the surface edges of this brain. But in that case, you would lose all the information on the inside. Now, if you do a volumetric render, you sometimes have problems because of occlusion. For example, if you do a point cloud, all the points on the outside might occlude all the ones on the inside, etc. And so to get around this problem, we've developed something called fishnet and crosshatched fishnet rendering. Okay, and to demonstrate that, we're actually going to use a much lower resolution brain than this, just because we have to work with a smaller number of voxels. So this is resampled that nice high-res brain into 0.7 millimeter, into 6 millimeter isotopic voxels, and so that you have about 7,500 voxels inside this brain. Okay, so it's a little, you can see it's a little poor to see, but it's still good enough for our purposes. And to make it more interesting, we've also created a little fake brain lesion in this person. So you can just pretend that you have a mask for an underperfused brain region as well as a core lesion area in this person. And how can you visualize that in a three-dimensional space so you can get just sort of an idea of the 3D properties, not just these slices here. Okay, so I'm going to bring up first our rendering here of what the surfaces for those 3 volumes would look like. And this is very useful already. You see something like this in many applications. But as you can see, you don't really get a good sense of the interiors of this brain volume. It doesn't really tell you where those lesions are in relation to other structures within the brain. Okay, so what we can do is we can add to some surface model like this. We can add the fishnet renderings. Okay, and so this one we just rendered everything that had less than 0.75 signal intensity as green, and everything above that as white. But of course, you can have much more colors than that to get much more detail. At this level, we're just illustrating a concept, but you can see that just having these fishnet renderings inside of the surface model gives you a sense for the inner structure of this brain. And you can see that the white kind of looks like the white matter, and the green looks like gray matter. And with these fishnet renderings, you can resolve every voxel in this 3D space. Okay. And then we're just going to add those lesion masks again. Okay. So what else can you do? You can also add something called crosshatched fishnets to this. Okay, if you want to display the lesions inside. Okay, so we did that. Oops, here. All right. I'm going to actually take away the volume renderings of that. Okay, so you can see that with these crosshatched fishnets, you can get a sense of where that lesion is inside this volume. Okay, and you can also sort of mix and match what you want to see when you see a volume like this. You can take away, the other fishnets to see something just like this inside to get a better look at the lesion, or maybe some sort of cortical structures, etc. All right, so that's the end of this demonstration of crosshatched fishnet rendering. If you have more computational power, or you can use GPU accelerated computing. You can do a faster render. You can do a more detailed render. And all of this will improve the ultimate 3D model that you end up with.